Reading material is a body of work that rejects knitting for garmentry, instead delivering an exploration of tactile language, bookmaking, written language, and translation. To justify the importance of new approaches to old systems, designers must work interdisciplinarily. In the 2018 publication, Why Materials Matter, Liz Corbin, a materials researcher and designer, stated, "The skill of the 21st century's thinkers will not be cleverness in one particular discipline, but rather knowing how to use materials as a bridge between mediums." Textile is a universal language. In all of the cultures of the world, textile is a crucial and essential component. Sheila Hicks. Many have studied the relationship between storytelling and weaving throughout history, while knitted pieces are not often explored conceptually beyond a utilitarian purpose as garments. The research for this body of work was conducted through interviews, witnessing museum lectures, and quite a bit of reading. After researching narrative and functional interactions between textiles and text, the opportunity arose to create a collection of knitted material experiments as meditations on language. Reading material studies find meaning in a cross-industry hybridization by applying a knit process to everyday language-related tools, including paper, a book, a digital font, and a packaging material. The surfaces engineered for reading material derive their form from atypical knitting fibers, including monofilament, spandex, paper, and digital code. Then, just like any artifact, each exploration works within the framework of an era-specific resource, including stole machinery, software, and a digital font-making service. While textiles have long been considered a storytelling medium, there is a specifically linguistic logic to knitting. For example, knitting is documented by way of knit notation, a series of symbols that describe actions. Notation takes knitted loops into a purely digital space as a typeface. After deriving glyphic characters from my own paintings, I then assigned loops and the transitions between them to keys that were oriented to represent the front and the back of a knitting machine. Although the notation font was designed as a user experience, the font took on the form of a printed artist book, featuring some process snapshots and the actual knit notations used to create the book sock and book cover. In another material exploration, a product called airless bubble wrap was formed, then translated for its own successful industrialization. Airless bubble wrap uses knitting structures and a unique fiber combination to achieve a surface with a similar aesthetic and identical function to bubble wrap. Since the cushioning bubbles can't deflate, the product is designed to remain in perpetual circulation. Airless bubble wrap is durable enough to reuse and special enough to keep. In the context of my thesis, this exploration was about translation. The airless bubble wrap material, appearing as a book sock protecting the knitted book, was first materialized on a PASAP Duomatic knitting machine. Then, the knitting instructions were translated into M1 Plus software. After that original file was written, airless bubble wrap formed on a Stoll ADF machine at the Manufacturing Solutions Center in North Carolina. I went about trying to achieve the same results through a variety of programs in different industrial knitting machines, straying from the original PASAP structure until I reached an identical result. In the end, a sample of the PASAP execution of airless bubble wrap and a sample of the Stoll execution of airless bubble wrap appear to be almost identical. However, months of programming language and technological learning separate the two samples. My exploration of knitted textiles began as an interrogation of the similarities between the printing press and modern industrialized knitting technology. Through many studies exploring textiles knit from paper yarns, it became clear that the best way to present knitted paper would be as a book. At first, the knitted book's pages were designed with the intention of using a saddle stitch binding to join them. The idea then evolved to mimic an accordion fold so that the book could be knit across the almost full width of the knitting machine. By combining simple knitting structures into rectangular blocks, the tubular sections serve as the margins of the paper, while the single jersey and pointelle function as the body. The vertical stripe running through the center of the artwork file represents a narrow column of backbed stitches that allow the knitted document to fold in half. In publishing, this crease in between facing pages is referred to as the gutter. Across the book publishing industry, paper is cut to size, creased, embossed, and debossed after the paper has been formed in a printing press. By knitting the pages of a book, all those steps are combined into one process. By combining paper, yarn, strategic layout, and the exploration of knitted pages, we're scratching the surface as to how industrial knitting technology could function as a more process-efficient paper press. The fabric used in the final book cover is a double-bed fabric made from washi polyester yarn and raffia. The fabric's composition drew inspiration from the successful flat design elements of the stole-knitted accordion pages by incorporating undisrupted tubular borders on all edges of the paper. The washi poly yarn floats across every other cell of the fabric and is knitted down in their neighboring cells. The raffia is then diagonally woven through the negative space between the layers of the double cloth fabric. Here, in the cover's final iteration, the raffia integrates mysteriously into the fabric while stiffening the hand so that it may function as armor for the book. While the book cover is angular and weighty, the book sock approaches armor in a much softer way. The book sock uses a material of my own invention called airless bubble wrap to form a protective, detachable layer around the book. The book sock serves as a binding because it joins the covers of the book together. However, if the covers are not joined, the book is able to relax into an unfolded accordion state. Taking inspiration from Butterfly Conservatory's Reading Materials December 2021 exhibition at Thomas Jefferson University displayed the textiles as studies and field notes rather than resolved consumer-ready fabrics. The experience was designed to inform the viewer about the diverse experimentation involved in creating a single material.